Hi, I'm Brent Felker, Chief Engineer at Caltrans. The Director and I appreciate the tremendous job that Caltrans construction staff and our contractors do at building and improving the state's transportation system. We'd also like to ask that you focus on another challenge, protecting and enhancing the state's environment, specifically to keep soil and other pollutants from your projects from entering the state's storm drains and natural waterways. We're confident that you will meet this challenge, that you'll do your part so that all of us, our children and our grandchildren, can continue to enjoy swimming in our lakes, fishing in our bays, and drinking clean water. Thank you.
I think it's very difficult to make people understand at a field level that they are ultimately responsible for controlling sediment.
If we could figure out everything the contractor needed to do to control stormwater pollution on the site, we would do it. However, we have to leave the contractor some latitude in how he's going to do his work.
People believe that that is impossible to do, and they just give up on it, and they just go to a list of tables and say, I'm going to do this one thing, and as long as this one thing is in place, I'm safe, and that is false.
It's not easy to keep sediment on your site as you carry out major construction, but it can be done. In this video, we identify the temporary best management practices, or BMPs, for minimizing erosion and controlling sediment. We'll demonstrate how to install these temporary BMPs correctly. We'll inspect some sites and see maintenance and repairs in progress. And we'll show you sites where BMPs are combined effectively to prevent pollution. First, some basic techniques. Blowing and spraying materials onto disturbed soil areas is a common temporary BMP to stabilize soil.
How many layers? Just one?
Yeah, just one.
Just two.
Maybe up here on that bridge abutment we might put more than one.
Okay. And then here, it should be along this one.
Right, I think that'd be more effective.
Straw is blown onto this site to prevent erosion. Less erosion here means less sediment to control downslope. A tackifier or glue holds the straw in place. This method is effective for temporary erosion control on flat or moderate slopes. On this site, straw protects soil and seeds until grasses are well established to provide permanent erosion control. Straw rolls have been added on some slopes to help prevent erosion. On other sites, wood fiber mulches are combined with water and a binding agent or glue. Then they are blown on disturbed soil to create a temporary cover. Bonded fiber matrix, for example, dries to form a stable surface that resists erosion. These mulches do break down. They must be maintained until they are replaced by permanent landscaping. Problems must be corrected. On this stretch of new roadway, some BMPs have deteriorated and some are not yet completed. Eroded areas and rills must be filled.
Yeah, Joe Kiwi needs you to go up to wall 451. He's got a little bit of, you got to cover a class 2 pile up there and put a little more silt fence in and fix some of the fiber rolls. What'd you hear about rain?
60% chance.
Okay.
So trying to prepare.
This silt fencing is not properly installed. The red witness line is exposed. It should be buried.
What I'm gonna do is this, I'm gonna bring some of the dirt in with the blade on an angle, and as we go along, you go ahead and take the dirt out so we can have the space and not to destroy the shoulder. And get your witness line parallel to the top of the shoulder itself. And that's routine right there.
Yeah. As long as you know the red line doesn't show.
Okay,
These men are installing the fence correctly. The ditch is deep. The stakes are driven in well. The bottom of the fence is buried to the red witness line and keyed in solidly. Water will not run under it. The fence will hold sediment until it settles out. The fence section is stable, with 6 inches of fence material buried. This section is tightly fastened to the next by wrapping the fabric completely around each stake, overlapping the stakes, driving both stakes in together, and fastening the tops of the stakes with wire. Fiber rolls are installed at the toe of this slope to stop sediment from running down the road into storm drains. The rolls can also be installed at intervals along the slope to divide it into shorter sections. This slows runoff and reduces erosion. Fiber rolls are easier to install than silt fence and require less maintenance. Because this slope is long and steep, mid-slope rolls must be installed to control water and soil movement. The rolls are installed in a trench. Stakes are hammered in every 4 feet to hold them firmly in place. After the rolls are installed, the loose soil will be stabilized by an approved BMP. The disturbed and bare soil surfaces along this highway still need some type of soil stabilizer before a rain. This could be sprayed on mulch and tackifier or other approved BMP. Otherwise, the soil will run off the hill onto the highway and into the storm drains. Soil stabilization and sediment controls are always necessary, but even when they are in place, you must protect stormwater inlets as well. Storm drain inlet protection should be installed in accordance with Caltrans approved BMPs. Mulches, soil binders, silt fences, and fiber rolls are not always adequate to control sediment from steep slopes with concentrated water flows. Straw mats, other erosion control blankets, or plastic sheeting can do the job. They must be installed correctly. The mat should be held in close contact with the soil and fastened securely at the top. This prevents water from running underneath the mat and eroding the soil.
Yeah, cut the piece right here so you can put it in the water wall.
The gravel bags next to the bridge direct water to prevent concentrated flow and erosion near the bridge abutment. So far, we've looked mostly at examples of individual BMPs, but even in these cases, contractors and engineers combine several techniques to hold dirt in place and keep it out of storm drains. On large, complex sites, solutions are not always obvious and may take time, trial and error, and even failures to figure out.
It's difficult to understand just from looking at the site, but this job, especially this part of it, actually receives water from off-site. Our job is not only to be aware of what we can see, but also be aware that we can receive major quantities of runoff from off-site, and we have to be able to control the water without losing our sediment. A lot of what you see is a result of this is our third winter, and we've tried different things, and we try some things that didn't work too well. We come back and try a combination of things. For this winter, I think everything's worked pretty well, but we've been practicing.
This project must protect the site from stormwater run-on, the rain falling and flowing on the large site as well as from groundwater. This sequence of large line ditches with check dams to slow the water, high earthen and concrete covered dikes, this large detention and desilting basin with primary and secondary outlets, and the many other BMPs should have been able to handle the water from an unexpectedly large rain event. But one large outlet got accidentally blocked just before the rain. Some of the water ran out into this neighborhood, flooding the street. All of the measures have been repaired and improved to handle any future flooding and to prevent pollution. This site used temporary open ditches to channel massive water flow. Closed drains can also do the job.
This is kind of in the middle part of the winter. It's not usual to be excavating this amount of dirt at this period of time, but they have a window of opportunity. They can excavate this with preventive measures in place to use as they need be in case of a rain event.
This project is directly above the Carquinez Strait leading into San Francisco Bay, so it's essential that no sediment leave the site. BMPs have to manage large quantities of water. To control run-on, a large temporary slope drain system was created. Using slope drains and other devices, run-on is routed through the site and back into the storm drain system without coming into contact with disturbed soil areas.
Originally, the contractor who was doing all the excavation took it upon himself to open up more area than really was specified in the specials, which is 2 hectares. Now 2 hectares is an awful lot of ground to have open for a situation as this as we're on this side slope. And then some of the measures weren't in place that I kept insisting upon, and slowly after we got inundated by several rains, they started to place the measures that showed them where the problems were.
To cope with rain and water that can't be kept off the site, ponds, basins, and traps can be built. They capture and hold sediment and water. If the trap is large enough to handle the expected volume and long enough to retain the water for some time, significant amounts of sediment will settle out. The cleaner water can then be filtered through gravel and routed to the storm water system. As part of regular maintenance, accumulated sediment must be removed from the trap and the structure maintained so it can do its job in the next rain. The basin around this gravel filter and pipe has completely filled with dried sediment and can't be seen. It too will need to be cleared and repaired. Particularly on projects with large and steep slopes, the best strategy against erosion is to button up inactive disturbed areas by applying soil stabilization and erosion controls as soon as grading is nearly complete. In the rainy season, all projects must follow strict guidelines to limit the size of both active and inactive disturbed areas.
The most difficult thing for both the contractor and the state's representative is to plan ahead and basically be aware that when you open a site, do some work, you're expected to close it down when you're finished. Very often contractors don't think about that. They figure, the more they keep open, the more options they have. That's been the custom in the past.
Heavy rains put temporary BMPs to the test. When projects grade and regrade very large areas and include steep slopes, it's a challenge to design and install temporary best management practices that will hold soil in place. The Penasquitos Creek crossing presented difficult design and management problems.
One of the problems was during construction we had 1.5 to 1 slopes coming right down to the edge of the creek here. And while we're trying to build a bridge up above, this was the most critical part of the job, with the crossing at the north end here. We had a couple of freak storms that put more water through this creek than we anticipated, and actually topped the crossing at one point. That was rather devastating through that area, and washed out all of our protection through the creek at one point. Now that's all been rebuilt, and you can see the pictures of what it looks like now. Now what we've done in here is we've got bonded fiber matrix on these steep slopes, fiber rolls breaking up the slope. We have hay bales along the edge of the creek with a silt fence as well. And the base of the slope where you see these X's here, but the bottom third of the slope in addition has jute mesh on it with the bonded fiber matrix over it. This is very well protected, but still it's on a temporary basis. The permanent landscaping will go in as soon as we can get permanent water source in here to do irrigation.
Because of the failure of the BMPs and the sensitive nature of the creek, the project water pollution controls had to be redesigned. Much stronger measures were installed.
This job was difficult because we have these two sensitive creeks. We have a job to do, and that's to build bridges and to build roads. At the same time, we have to, be diligent about making sure that we don't have any sediment going into the water.
Regular inspections reveal when BMPs need maintenance. Even the very strong measures used here need maintenance. Broken fiber rolls must be replaced and restaked. Jute mesh was installed for its extra strength, but still needs some repair. The bonded fiber matrix is breaking down and needs to be reapplied. The silt fence and hay bales also need repair.
To do, just take it out, bring a couple of more hay bale sections, and just that should work better.
Okay.
The gravel bag check dams will slow water rushing down this concentrated flow area. Like all BMPs, they must be maintained. The mud that has been trapped behind the dams must be removed. Soil that is removed must be disposed of properly so that it will not wash down the slope again. If soil is collected and stored, it must be protected from rain by covering or stabilizing and by installing linear sediment barriers. To maintain the check dams, bags must be correctly stacked and broken bags must be replaced. The check dams and other BMPs should protect these newly planted native shrubs and the newly restored creek. Soon, permanent landscaping with native plants will be installed to hold the cut-and-filled slopes. As this highway advances along creeks and above valleys, highway designers and builders will continue to discover and cope with new difficulties in preventing pollution of creeks and storm water systems. This project shows in a very vivid way the challenges faced by all Caltrans staff and contractors as they work to build highways and bridges and to preserve California's waters and its natural beauty.
There's a lot of variabilities on the site. Sometimes we have to get creative.
What's more difficult to do is to actually look at your whole site and understand that maybe you try one thing and that's going to be enough. You need to try a combination of things.
You know, there are a lot of different stages that we go through in order just to build. And at the same time, we have to maneuver in order to protect and build and protect and build. And that's how we've done the job.